Good afternoon, everyone. We will start our lecture today on continuing on our schedule. So for this week, we should end homogeneity and the mean value theory. I will talk with you today about the MVT, the mean value theory. For just only real valued function, I will leave the several variables for next time, inshallah. You will have on Sunday, you will get more time just to go through it, okay? And to feel comfortable with these type of problems. The mean value theory is one of the important theories, general, as it has a lot of applications. It's very, very simple. What states that if I have a function which is continuous, number one, number two, differentiable, so it has two conditions, you have to be sure about them in order to get advantage from using the theory. The first of them is to have a continuous function and also differentiable within the interval from A to B, for example. What states is, if you have this function, you will have some value of C within the mid-range or within the range from A to B, for which the instantaneous change or rate of change will equal to the slope that, or the rate of change that connects these 2 points A and B. So the direct application is f dash C equal f of B minus f of A within B minus A. So now once more, for any function f of x, which is supposed to have just only two conditions, it is continuous on the interval of the domain A and B, and also differentiable within the interior of this interval. So if you have like this is the x-axis, y-axis. If your function is like this, for example, and you have an A and B, this is the domain that the function is defined continuous and differentiable, as I told you. You will find at certain points within this interval, maybe here, C1, C2, whatever, maybe just only 1 point, you will find the instantaneous rate of change, which means the derivative of the function at any point or at some points, equal to the slope that's connecting the values between fa and for f and b. This is all applied from the rule by itself, the MVT, which says that f dash c equal to f of b minus f of a divided by b minus a. Of course, c belongs to the interval, which is a and b. This is the exact or the definition of this. You should memorize it very well. I've wrote all of this in this slide, and I will send you these slides within the next week, okay? Because I've added also the various variables on it, so it will be all together sent to you, okay? So the definition, let f belongs to AB, it's a function that satisfies continuity first of all, differentiability. So before you use this theory, you should be sure about these 2 points. Okay, what's going to happen? That I can find f dash c, which equal f of b minus f of a divided by b or b minus a. The theorem guarantees that some point c within the interval where the instantaneous rate of a change, f dash c equal the average rate of a change. Let's apply MVT theory on this piecewise function. First of all, if you look to this function, you will find that this function is defined on more than one domain. The first of them, or the first part, or domain of this function, it's 3 minus x squared over 2, and it runs in the period of x less than 1. Then f of x will equal 1 over x, and it goes for x is greater than or equal to 1. We want you to justify the mean value theory on the interval between 0 and 2. So actually 0 and 2, it's taking the 2 wings together. Are you with me? You understand what I'm saying? شباب دينا فاهمين اقول ايه؟ اوكي انت عندك هنا بوينت اللي هي عند 1 الانترفال اللي انا هستخدمها هي 0 ومين؟ و2 يبقى before we use this theory we should number one check for continuity. Do you remember how to check if a function is continuous or not? Do you remember? Okay, I will tell you. Of course you remember it's just only 3 steps that you should check for any function to be sure that if it is continuous or not. So I will start in order to justify if the mean value theory will be applied to this function or not. I will start by writing the function f of x, which is 3 minus x squared over 2, and this is for the value of x less than 1. Then it's going to equal to 1 over x, and this goes from x greater than or equal to 1. The first condition is to be checked is continuity. Okay, for a function to be continuous, you should be sure that it is connected through all the domain. But the problem is we have for the domain which is 0 and 2, we have a point at which the function is defined by more than one function. So what I have to do now is to get number one, the value of f of x at x equal to 1. In order to get the value of this function at x equal to 1, I will be forced to use this part. So the result will be 1 over 1, so it's just only 1. Number 2, I will have to find the limit of x tends to 1 positive for this function f of x, and also getting the limit of x tends to 1 negative for this function. And they should be equal to each other to have a limit. So for continuity, you should check 3 main points. Number 1, the function is defined. This is number 1. Number 2, the limit exists. And the number 3, both of the two values equal to each other. So shahd, the first of them, is to get the value of x of this function at x equal to what? 1. For x equal to 1, remember that I can't use this part. I can use only this part. Do you know why? Because it is covered in the condition. Yes. So once you make a substitution, it's equal to 1. I will try to get the limit. So limit f of x when x tends to positive 1 is going to equal to limit x tends to 1 from the positive side. In this case, I will use f of x which is 1 over x. So it's going to be 1 over x which equal to 1. Same way like I will do it, but from the negative side, the negative value of 1. This is why, Dina, I will have to use the other way, which is going to be 3 minus x squared over 2. And once you start substituting, you will have 3 minus 1 over 2, which also equal to 2. And this assures that the limit of f of x, x tends to 1 positive, equal to the limit of x tends to the one from the negative side for the same function. So already the limit exists and it equal to 1. Either this is number 2. Number 3, both the definition and the limit should equal to each other. So actually f at 1 equal the limit of x tends to 1 for f of x. This means that this function is continuous at x equal to 1. Now Dina will ask me, now we are sure that this function is equal at x equal to 1. But is it equal for the whole period that I want to apply the mean value theory? Yes. Do you know why? Because for the period that starts from 0 up to 1, we have just only a polynomial, which is continuous. And also for x is greater than 1 up to 2, we are dealing with a rational function, which is 1 over x, okay? And there is no problem with 1 over x through the interval from 1 to 2. So this function is continuous on all the x values belongs to starting from 0 up to what? Up to 2. So the first condition is okay. The second condition is to check the differentiability of this function at or inside this interval. So as I told you, I will start with checking the continuity by checking these three steps. The definition exists, the limit exists, both of them equal to each other. Then I will go to differentiability. This is the definition. These are the limits from the right, from the left. Both of them equal to 1, so the limit existence equal to 1. The second step, of course, it is continuous, since both wings belongs to a continuous functions. One of them is a rational function and the other is polynomial, so it's continuous. Now I will have to study the differentiability. How to study the differentiability? If you remember, I can use this limit. Limit of x tends to 1 positive, f of x minus f1 at x minus 1. And they check this limit with limit f of x minus f at 1 divided by x minus 1. Let's check if this limits exist or not. If this limits exist, that means at x equal to 1, this function is differentiable. In order to do so, I will start just only substituting. Shad, please do it with me. Okay? Step by step. I will start with this part. Since we are talking about 1 positive, so which wing we will use? So I will start here in order to check number 2, which is differentiability. I will start, as I told you, with limit x tends to 1 positive. This way, Dina, I will have to use this guy. So it's an f of x, so I will consider f of x minus f at 1 positive divided by x minus 1, the difference between these 2 points. So f of x is going to be 1 over x minus f at 1, so if you make a substitution, it's going to equal to 1, divided by x minus 1, taking the limit from x to 1 positive. Any ideas what should I do? Okay? If you try to substitute, you will end up having 0 over 0. In order to go over this problem, all I have to do is to get the 0 factor from the denominator. مين اللي عامل عندي مشكلة في الدenominator؟ x minus 1. يبقى لازم x minus 1 to be removed. How can I do that? It's very, very simple. All I have to do, maybe I can multiply on x over x, or I can take 1 over x as a common. If I took 1 over x as a common from the denominator, I will have 1 minus x. Is this correct? Divided by x minus 1. Am I correct? Is this okay? Okay. The second step. I will take negative sign from the denominator. So it's going to be a limit over x tends to 1 positive. Taking the negative, so it's going to be negative 1 over x. Now I have x minus 1 divided by x minus 1, which will cancel each other. And the limit in this case will be limit x tends to 1 positive for negative 1 over x. And you will end up having negative 1. So from the right side, or from x positive greater than 1, this shaft, the value is equal to negative 1. I will do exactly the same, but from the other wing. How to do it? I will go through limit of an x tends to 1 negative, and in this case, I will do exactly what I did before, but with the definition of the function from the other side. So simply, it's going to be limit of x tends to 1 negative. F of x is going to be 3 minus x squared over 2 minus the value of the function at 1, which should be evaluated from here, which is going to equal to 1, divided by x minus 1. I will now have to find the value of this limit. Not just only to find the value, but also to be sure that it is equal to negative 1. Okay, Dina? So how to do this? I will multiply in denominator and denominator in 2 in order to get rid of this value of 2. If I did so, I will have 2 at the limit of x tends to 1. And on the denominator, I will have 3 minus x squared minus 2 divided by x minus 1. Is this okay? Okay, perfect. The second step, I will do the following. This is 2, and that's the limit of x tends to 1 negative. Once you start simplifying the denominator, you will end up having negative x squared plus 1 divided by x minus 1. In order to make things easier for you, I will take negative sign from the denominator. So it's going to be negative 1 minus, so it's going to be x squared minus 1 divided by x minus 1, which is going to be a limit for x tends to 1 and negative. This is the 2. Start factorizing, so it's x minus 1, x plus 1 divided by x minus 1. I will cancel these two brackets together, so I've already removed the 0 factor. And this limit will equal to a negative of, once you start, just a second, I'm sorry, we have taken 1 over half, so it's 1 over 2, 1 over 2, I'm sorry, 1 over 2, so it's going to be negative 1 over 2 times 2, which is going to be 2 negative 1. شباب انتوا عارفين الاثنين دي جت منين؟ الاثنين اللي في الاخر دي جت منين؟ معايا دي؟ منين؟ عملت سبستيتيوشن صح 100 1 بلس 1 راح مديني 2 دي. وطبعا انا واخد من الاول half as a common وبالتالي دي cancel each other. طبعا if you remark, this is the limit from the left, this is the limit from the right, they both equal to each other, so it is differentiable. This is what I did here exactly. This is x equal to 1, so it's going to be 1 over x minus 1 over x minus 1. Similar manner, I will take x as a common, or get x from the denominator and multiply, so I will end up having this shape. Cancelling the 0 factor from the denominator, I will end up having negative 1. Exactly in a similar manner, but using the other part, which is going to be 3 minus x squared over 2 minus 1, divided by x minus 1, multiplied by 2, or taking it as a common, cancelling the same, I will get negative 1, so it is differentiable at 1. Now I have the two conditions already satisfied. So what I can do now is to get benefited from these two conditions by applying rules theory, which states that there is certain value of c at which f of b minus f of a over b minus a equal f dash c. So now I will start doing this analysis. What we may find here is a typo in the main slides. I want to show it to you here, then I will fix it. So there is a minor error here, this value is not correct. I will show it to you in the next slide. These are the values, so all of this is not correct. I will start from here once more. So now let's make a substitution. Now, once more, this is f of x equal to 3 minus x squared over 2, and I have 1 for x. This is for x greater than or equal to 1, and that's for x less than 1. This is the function. I will need to check MVT where x belongs to the interval 0 and 2. Okay, let's start. Okay, the condition states that f dash at c equal to f of b minus f of a divided by b minus a. So all I have to do is to start substituting. So I will go for f of b. شهد دقيقتين بالظبط. خليك معايا بس دي وانا مش هقدر. ماشي؟ بس عايز اشوف الحاجه. انا هبدا to substitute from f of b minus f of a divided by b minus a. الانترفال اللي انا بتشيك عليها 0 and 2. So this is for A and that's for B. So let's start. F at 2, I will have to use this wing. So it's gonna be 1 over 2 minus F at 0, which is A. So I will have to use this part, which is gonna come up to 3 over 2, divided by B is equal to 2 minus A, which equal to 0. Once you start doing this, you will have a half minus 3 over 2 divided by 2, which is gonna get to negative 1 over 2. Now I have F dash at C equal to negative 1 over 2. The question is, which part of f of x I should use? This is why I will divide this problem into two sides from here. I will test this relation with the first one, then I will also test it with the second one. معايا دينا؟ Okay, so all I have to do is to consider first the first part, which runs from x less than 1. So within this interval, I will be studying for the time being from 0 up to 1 open through this interval. I will apply the mean value theory, which means I will start differentiating this function. So f dash x will equal to negative over 2x over 2, which equal to negative x. Which means that at this period, I will have f dash c, which is negative c, and it should equal to negative 1 over 2, leaving me with that at c equal half. Within this interval, I will have a value at which the rate of exchange of the function equal to the rate of change of the line connecting these 2 points. In a similar manner, I will go for x is greater than or equal to 1, and also within the interval of 0, 2. So the interval that I'm going to talk about is 1 and 2. Similarly, but through this interval, I will have to use this part. So I have already f of x equal 1 over x. F dash of x is going to equal to negative 1 over x squared. So f dash at c is going to be negative 1 over c squared. And all of this value should equal to negative 1 over 2. That's c squared equal 2, which means c equal root 2. Guys, do you know why I've taken just only positive 2? I'm taking the positive of the square root because I'm just talking about the interval between 1 and 2. So the other square root I already neglected. So once more, everything is okay. I will start substituting f2 minus f0 over 2 minus 0. But remember, f2 should run on the upper wing, and that's on the other wing. I've made the substitution, it's negative 1 over 2. I will study case by case, the case at which c equal to 1. So I will use this wing. The derivative is going to be negative 2x over 2, which means that f dash x will equal to negative x. So at c it will equal to negative c. Now all I have to do, Dina, is take negative c, make it equal to negative 1 over 2, which means c equal to half. That's it. So this is the first point. Okay, once more, I will start to go through case number 2, which states that I will go for the case if c is greater than 1. In such a case, the function that I'm going to use is 1 over x. I will start differentiating, which is going to be negative 1 over x squared. Of course, I will erase every x by c, so it's going to be negative 1 over c squared. Now, I will put them equal to each other, getting the value of c, which is going to equal to root 2. There is another example on the application of the mean value theory, and I will leave it for next time. Hopefully, try to go through it. You already have it on the next slides, and I will explain it later, inshallah, within the next lecture. Thank you very much for today. I know you are very tired today, so I will stop right here, and I will continue next time. Thank you.